Okay, so today basically I go to the basic thing we need to know in order to be a technician. You understand the technician is not assembler. We try to fix the circuit board. Some circuit wrong, that is your job. How to fix it. So that's why the job will be get paid more and also more skill. If you know how to do what to do, you will be okay. Okay? So now in here, they're telling you you get a DC direct current, AC alternate current. Okay? Normally a DC, if they display on the oscilloscope, that's a time domain, and you see they just one line telling you 12 volt or whatever voltage. For example, they say 12 volt. You know DC in your car battery, 12 volt, that DC. Okay? That means the current flowing only from positive to the negative. And this is a symbol for the DC battery. Okay? And another one they display this is, you understand, a alternate current. Okay? And the signal here, we call a sine wave. If you're looking using the oscilloscope, you're looking in the outlet of your house, you see this signal. Okay? This signal will be, this is a positive, and that will be negative. So when the positive, the current supposed to flowing from left to right. However, when the negative, the current flowing right to left. So that's why they call alternate current. Okay? So this is the symbol for the AC signal. Now, this is not much thing to talk. We have to talking about that AC signal. Like I just showed you. That is the sine wave. In here they say signal name, sine wave. Time domain, what that means? Time domain, that means the signal vary with the time. Okay, that is the time domain. If the signal vary with the frequency, so that will be frequency domain. So you get two domains. One will be time, okay? And one will be frequency domain. And time domain will be displayed on the oscilloscope, okay? Oscilloscope. Frequency domain will be displayed on the spectrum analyzer. Okay, they try to see what that means. Time domain, amplitude vary with the time. V peak, that means the voltage from 0 to the top or 0 to the bottom. That's what they call V peak. And the voltage from the bottom here go to the top. That's what we call V peak to peak. So that is just the definition. Don't ask me why. Okay. when you want to learn technician or engineering, that is the basic thing. When you're looking into the signal, you know that is a sine wave. And the V peak equal 0 to here, 5 volt. Okay, that means V peak equal 5 volt. And V peak to peak, they will be double V peak. So you can see here, V peak to peak equal 2 times V peak, so they will be 10 volt. Okay, and the next thing, you can get the voltage they call VAC or VRMS. Okay, also they call VAC. Or VRMS. IMS means root, mean square. That's what we're talking about, effective voltage. Okay, now see what that means. That means the voltage from here to the bottom, you get 10 volt. However, when you apply into your circuitry, it's not 10. Okay, only a certain voltage will be applied. That's what they call VAC or VRMS. Okay, if you using the oscilloscope to measure the voltage here, and in your outlet, okay, they will be show you a big sine wave. That's around 340 volt peak to peak. Okay. Okay, one student asking the lab, that means at the University Avenue. Okay, Mr. Sam will be given to you the location. Okay, so basically, if you're looking on your outlet at your house, using scope, you can get the peak to peak will be around 340 volt. Okay. However, if you will using the meter DMM to measure, then you can get 110 volt or 120. That will be effective voltage, or that will be called VAC or VRMS. So if you get the V peak, you want to calculate the VRMS. I already given you the formula right here. Take 0.707 times V peak. That's what you get VAC or VRMS. That we're talking about the voltage. Okay. Any question about the voltage? When you're looking into the signal, you have to tell me that is a sine wave. Okay. V peak equal 5 volt. Peak to peak equal 10 volt. And VIMS will be calculated by 0.707 times V peak. That's a minimum thing you must know about the voltage.
Is the house voltage 115 or 120 or 110?
They can be 115 or 120. That will be VAC or VIMS. Okay. Now we're talking about frequency. Okay. T period. That means you can see from here, go up, going down, going up. That complete one cycle. We call a period T. Okay, complete one cycle. In this example, this is the time right here, 0 millisecond. Okay, right this point, 0.5 millisecond. This will be 1 millisecond. So the period in this picture shows you period in equal 1 millisecond. Okay, and if you want to calculate the frequency, you have to using this formula. F equals 1 over T. In this formula, T must be in second, F will be in hertz. If you get the frequency, you're able to calculate the period. Okay. Now, this is a very basic for you. Try to define something. What is a cycle? One complete occurrence of repeating wave periodic signal, such as one positive, one negative alternation of a sine wave. That means they get positive and negative. That will be defined as one cycle. What is the frequency? Frequency is the number of cycles of a signal that occur in 1 second. Okay? And the period, the time distance between two similar points on a periodic wave. So when you're looking into this signal, you're able to identify the peak to peak where I am at, what is the period, what is the frequency. Okay. If you get any question, and just stop me, let me know. You understand how for this program to run. The thing is the level of the student is not the same, different. So that's why I have to go from the basic. Okay, now we're talking about something we'll be using. Okay, power. 1 million. Instead to say 1 million, you can say 10 to the power of 6. The thing is you get 1, 2, 3, 4, 5, 6. That's the power of 6. Power of 5, 4, 3, 2, 1. 1 will be equal 10 power of 0. And another way, if you get 0.0000001, then now you can get 10 to the power of -6. You can see 2, 4, let's see, 1, 2, 3, 4, 5, 6. Okay. So you go from right to the left, you get -5, -4, -3, -2, -1. 0.1 equivalent to 10 power of -1. Okay. To handle with the large number in electronic system, you power of 10 notation. That means 10 to the power 1, 2, 3, and so on. The number 10 equal the base, and its power equal exponent. For example, you get 247,000. Okay, 247,000. Okay, they want to put into the 10 power. Okay, the thing is a big number. So you can say you get 2.47. Okay, right here, decimal point right here. You can zap over 1, 2, 3, 4, 5. So instead, you're using 247,000. You can using 2.47 times 10 power of 5. They working the same thing. And another example, you get 0.00369. They want to 10 power. Okay. Then the first thing you get 3.69. Okay. 3.69. Okay. And now, how many number here? 1, 2, 3. So that's why 3.69 times 10 minus 3. This number or this number will be the same. But what I said, the thing is the number is too much number. That's why they want to using 10 power. Okay, to make it short. Okay, you get any question, anything? Okay, now multiplication and division using power of 10. To multiply number in power of 10 notation, multiply their base number and add their exponent. If you get 1.2 times 10 power of 3, everything times 1.5 times 10 power of 4. What they telling you to do? Take 1.2 times 1.5 first, and the power 3 and 4, add them up. That's what come up with 1.8 times 10 to the power 7. Okay? For division, subtract the exponential in the denominator from those in the numerator. Like they want 4.5 times 10 power 2 divided to 3.10 minus 2. You take 4.5 divided to 3. That's what here. And the power will take the 10 power 2 minus 2 minus 2. See what we get. 4.5 divided 3, you get 1.5. And 10 to power 2 minus 2 minus 2, you get power 4. That is the answer. Okay? So now, what I want you to do, calculate to see in the number A, what the answer. Okay? I need you to do it and let me know the answer. You have to be active in the program. Okay? If who get the answer, let me know. Anyone get the answer for number A?
Got the same answers that are on the slide. Yeah.
2.484.
Exactly, right here. And also in B, this is the answer here. Can you do to verify this answer right or wrong? So this is a very, very basic thing for anyone want to learn to be technician or engineering. So the answer will be 4.91 times 10 power of 3.
Would we need to give that answer as 10 to the power of 3 rather than doing 4,910?
So basically, you take the 98 to 100, divide 20, you get 4,910. And they're using the power.
So when giving our final answers, should we always have it as something between 0 and 10 as our first value? And then
1 and
times
10.
10 to the power of whatever?
Yeah. Okay, now I can tell you, make sure it's clear here. Basically, you divide, you get 4, 9. Okay, 1, 10. But the thing is, what they want is basically scientific notation. Okay. Later on, you can see. That means they want the first will be any number from 1 to 9. And the rest have to be power. That means in this one, they want 4.90. And then you have to be multiplied by 10. What the power? You can see 1, 2, 3. So that's why power of 3. Two numbers will be the same thing, 4,910 or 4.910 times 10 power of 3. However, this is the one we're using for engineering. Okay, that's what they call a scientific notation. The first number from 1 to 9 only. Then you can get the 10 to whatever power. So the correct answer, 4.91 times 10 power of 3. Okay, now you want to adding to power with the to number with the power. Okay, so what in general I can tell you, if they want to add in 3.25 times 10 power of 2 with the 5 times 10 power of 3. So in order to do it, make sure you have to make both get the same power. Okay, in this case, you want to make the same power of 3. this is the power of 2. And now you wanted to make it to be power of 3. So that's why you can add the number. You can see how they do it right here. Okay. They say, okay, they want 10 power of 3. So 50, okay, times 10 power of 2. Now, 3.25 times 10 power of 2. And you're adding 50 times 10 power of 2. Okay? Then you just add the number and the power keep the same. That means this is the first one. Okay? And this is the second one. Either way you want to do. You want to keep the power of 2, 10 power of 2. Both this you must change this guy. Okay? If you want to using power of 3, then you must be change this guy. In order you can add it. Okay, you can go through the solution. That will be helping you. But you have to exercise. Okay, let's see what here. Raising a number to power in the form of multiplication or division if exponent is negative. For example, if you get 2 times 10 power 3 square, okay, then you can say 2 times 10 power 3 times 2 10 times 10 power 3. 2 times 2 you get 4. 10 power 3 times 10 power 3. You add them up. That be power 6. Okay. And this will be a general formula. Also, integer fractional power represent roots. If you take square root of 4, you get 2. Okay. But the thing is that will be more easy when you get your calculator. Okay. You can get the answer. So this is the example here. I'm not go through it. Also, the thing is we already get the solution for you. You better try to do. And you can look into the solution. You can get the same answer or not. Okay. Engineering prefix. So power of 10. 10 now, power of 12, they call it tera. Okay. A symbol will be capital T. Power of 9. Giga. Capital Z. You know giga. You go to buy the computer. They will be asking you how many memory you want. So you get, okay, I want 4 gigabyte. That is giga. Giga means multiply by 10 power of 9. Mega, 10 power of 6. Kilo, power of 3. Milli, minus 3. Micro, minus 6. Nano, minus 9. And pico, minus 12. Like, you know, they say, okay, this capacitor is 10, 20 microfarad. If you want to change to the farad, you have to multiply by 10 to the power of 6, you know, minus 6. Now, example here. Convert 0.0 megavolt to kilovolt. Okay. This one you get the mega to kilo. If you're looking here, mega 10 power of 6, kilo 10 power of 3. Mega will be higher than kilo 1000. Okay? So if you get a 0.1 megavolt, you want to kilo, you take 0.1 times 1000. Okay? That will be kilo right here. 0.1 times 10 power of 3. This is the power. That means 1000. That's what you get 100 kilovolt. Okay. Number 2, express the following in engineering notation. You get 10 times 10 power 4. Okay. So basically, what you get, they want the power of 3. That means the power right here. That's what they call our engineering notation. Okay. You don't have a power of 4. So either you can go to power of 6 or you go to the power of 3. They must be here. So in this one, they will be go to the power of 3. If they going up, this got to be going down. Sorry. Power of 4 going down, power of 3. Then this have to be increased by 10. So that's why you get 100 times 10 power of 3, equivalent to 10 times 10 power of 4. But that could be engineering, okay, notation. Another one, 0.1 times 10 power of 3 watt, okay? And they can be 0.1 kilowatt. The thing is, you can see kilo right here, power of 3, okay? What is the basic unit? So the difference will be 1000. So that's why you times 1000, you get 0.1 kilowatt. Same thing. Last one, 250 times 10 power 7. Okay, second. Okay, let's see. You can get, they don't want power 7. We don't have any power 7 here. We get power of 6 or power of 9 or power of 3. So we pick 10 power of 6. Okay, that means you go this down 7 to 6. That means you go with this up 10 times. That's why 2500 times 10 power of 6. That's for engineering notation. Any question?
So for the
No.
powers, do you always go down? So like when you went from I'm not showing my screen, but like when you went from to the power of 7 down to the power of 6, do you always round the powers down to the nearest power of a multiple of 3, or do you round it up? Rather than maybe 2500 megaseconds, you would have 2.5 gigaseconds. Is there any reason why?
Just a minute, I get trouble here.
Oh,
Okay, now going back here. Okay, so yeah, go ahead.
Is it standardized to go up 2 rounds up or down
No,
on the multiples of 3?
doesn't matter.
Okay.
But you have to select either one here. They must be matching with the power here.
Oh, okay.
Okay. For example, you get a power 4, 10 power 4. We don't have 4 here. So you can pick 3. Or
Right.
you can pick 6, depending whatever you want. If you pick it 10 power 3, that means you're going down, right? 4 go to 3, that means going down 10 times. Then this number have to multiply by 10. So that's why 10 times 10, you get 100. And times 10 to the power of 3.
Yeah.
Okay. Now, DC here. You see that car battery. Okay. This is your headlight. When you turn on your headlight, okay, the current will be flowing from positive, go to the light, okay, and go back to the negative. That's what we're talking about, conventional current, okay? However, how do we get the current? The reason we get the current, the thing is, we can get electron moving from the left, negative to positive. Okay, that is the current, electron moving. So that's why you get the current. So most in the textbook, they draw the direction for the current, go from negative to the positive. That's what they're talking about, electron current. However, we're working with the conventional current. Okay, that will be telling you on the time, current will be flowing from positive to the negative. Okay, so when you turn it on, the light will be on. Now, this is an electrical current. Okay, when it's on, if you touch it, you can feel hot. That means electrical converting into the heat. Okay. What happened is, if it's broken here, the light not on. So that will be telling you current cannot flow it. Current will be equal 0. Okay. Resistance. Resistance is opposition to electric flowing. A component manufactured to have a resistance is called a resistor. Conductor like copper have a little resistance. So if you see this symbol here, that is resistor. Okay, and normally when you're working in the circuitry, you get the schematic. They draw it, and this is a symbol for resistor. This is the real resistor. The letter symbol ER. Unit of resistance is ohm, and also they can use this symbol. That's just a very, very basic definition for a new student don't know much about something in electronics. Okay, so that's just giving you structure of the carbon composition resistor just for you to get information. They've given you different type of the resistor. Okay, 1, 2, 3, 4, 5. Bigger will be handle more watt. Okay, like 2 watt. This will be a 1 watt or half watt, quarter watt, or so on. That means big one, they can handle more current. Okay, if you connect the high current to a small resistor, they burn out. Okay. Another different type. They show you this is different type of the resistor. They call a power resistor. So that's why when you're working on the circuit board, you see it, you know that is a power resistor. If you want to know the value, you can use a meter to measure. They're telling you how many ohm, kilo ohm, or whatever. Okay, another one also, they call a integrated resistor network. That means they make that, let's say, 1, 2, 3, 4, 5, 6, 7 resistor they put inside. Okay, they put inside. Instead, they connect by each one here. That take a lot of room. They don't want it. Okay, so that's why they can make a resistor like the networking here. Okay, 1 resistor, 2, 3, 4, 5, 6, 7. Take a less than space. Okay, in the circuit. Another one, they call a variable resistor. That means this resistor you can vary, turn around to get a different value. Okay. This one is fixed value, like 10 kilo ohm. Then that only 10 kilo ohm, you cannot get another value. However, this is a variable. They get 1, 2, 3 pieces. Okay. You can adjust this guy. They can give you different value. Okay. When you're working on in the lab, you can see. Now, this is a resistor. And basically, they're talking about color code. By looking in the color code here, you're able to tell what is the value of the resistor. Okay. And on color code here, they get 2 different. One they call a general purpose resistor, 4 bands. 1, 2, 3, 4. This another one we call a precision resistor, 5 bands. 1, 2, 3, 4, 5. Okay. So if the 4-band resistor, first band they call a first significant digit. Next will be a second digit. Next will be a multiplier. And the last one is tolerant. What's the difference between 4-band and 5-band? 4-band, the tolerance is basically not good. Precision, the tolerance will be higher. Now, what that means for tolerance? I try to explain to you. Like I buy the resistor, okay? Okay. equal 50 ohm plus minus, okay, 10%. If you get a resistor 50 ohm, you want to know the value. You take the meter, okay, the meter to measure, but you never get 50 ohm, okay? So that's why normally resistor have to get a tolerance 10%. So now we have to calculate to see what is a 10% 50 ohm. Okay, so 50 times 10 divide 100. Okay, so that is it 5, right? %10 of 50 ohm, that will be a 5 ohm. And now we have to know what the upper limit equal 50 plus 5. You get 55 ohm. And a lower limit $50 minus 5, you get 45 ohm. Okay, so if R equal 48 ohm, is it good or not good? If you get a meter
That's
to
good.
measure resistor, you get 48 ohm in this case. My question is it R good or not good?
It's good.
R will be good. Why? The thing is 48 ohm higher than 45 ohm, less than 55 ohm. So they be okay. So whenever you measure something, then they must get the tolerance. The thing is you say 50 ohm, no way you can measure you get 50 ohm. Okay? That's what they're talking about, tolerance. For the general purpose resistor, normally you get a 10%, okay? 5% or 20% tolerance. So that's why it's cheaper. You're going to buy general purpose resistor cost you maybe 5 cents. However, the same resistor, you want 5 band, you have to pay 25 cents. The thing is, the tolerance will be higher. They can be tolerant for precision, they can be 0.1% or 0.01%. Okay, so that will be telling you the difference between 4 band or 5 band. Now, this is the resistor color code. First one, take on a first digit. Next will be a second digit. The next one will be multiplied by 10 power of 0, 1, 2, 3, so on. And last one will be tolerant. So resistor get the color brown, okay? And brown and black. Then what is the value? Let's see, they given an example here to calculate it. Okay. However, that one just given you the precision different table. Okay. First digit, second digit, third digit, and next one will be multiplied and tolerant. If you understand this one, then you understand for precision. Only thing they add one more color. Now, this one. One, two, three, four, five. Okay. 5, that means precision, right? So the first one, they say brown. And you looking into here, brown, where brown? Here. Okay. So the brown, that's number 1. You can see that number 1 right here. Okay. That's the first digit. You get number 1. The next will be gray. Go here, gray. Will be number 8 for second digit. Okay. For first one, brown here. The next will be 8 here. Okay. Next one. Third digit. Orange. Number 3. Orange here. Orange right here. Number 3. That means you get 183. Okay. Now multiply by. Okay. 1, 2, 3. Gold tolerant. This one is not. Okay, let's see. What color? Gold. Gold right here. That's what they're talking about. Tolerant. Okay. 10 minus 1 is multiply. Okay. By 10 minus 1. Okay. Gold will be, let's see. Gold 5%, tolerant, and red 21%. Red will be red here. Okay, so basically this one is not really good for that thing. They calculate, let's see, 1/8 times 10 power 3. 1 here, 8 here. Third digit have to be 3, 183. Okay, so forget this one. Okay, this one I get from the textbook. The textbook is not given the right one. Forget that. We'll see another one. Okay. Let's see. A resistor manufacturer produce carbon composition resistor 100 mega ohm with a tolerance plus minus 5%. The question is, what will be the color code on the resistor? Brown, black, violet, gold. That is the answer. Okay. Now we calculate based on not precision. That one. What they say. 1 mega ohm. 100 mega ohm. They given you 100 mega ohm. And they asking what is the color. Okay. So the first one, let's see. Brown, black. Okay. This is number 1 here. First digit, that's number 1. Okay. Now that one, this one. Okay, general purpose. Mega ohm. Okay. So the first digit, number 1, right here. Okay. The second digit, number 0, that 0 here. So that will be a brown. And that will be black. Okay, now you have to multiply by what? In order to get 100 mega ohm. Let's see. They multiply by that one. Okay. 7. So the first one will be brown. The next one will be blue. No, violet. The next one will be third. This one. Brown, black, and violet. And taller than 5% gold. That is the answer for example. Okay. Brown, black, violet, and gold. And now, if they given you color and telling me, I just doing only number A. Brown, green, yellow, silver. What the value of the resistor? Brown, green, yellow. Brown. Number 1. Green. Number 5. Yellow. Here. That means 1, 5 times 10 power 4.
No.
1, 5 times 10 power 4. Tolerant, silver. silver 5%. Silver here 10%. So blood 10%. Okay. So basically that will be 15 times 10 power 4 ohm. Blood minus 10%. Okay. That will be telling you by looking into the column, you able to telling what is the value. Okay. Now, conductor G is defined as the measure of material ability to allow the flow of charge, and he assigned the SI unit, the Siemens. F. A large conductor indicates that a material is able to conduct current well. Well, a low value conductance indicates that material does not readily permit flow of the charge. Okay, basically, they just telling you one thing. Conductance will be G. G will be equal 1 over R. Resistor will be opposite to the current flow. And G will be a good conductor. Let more current flow. Okay, they will be opposite. Okay, and the unit of the conductance will be a Siemens F. Okay, and resistor will be in ohm. And they want to know the conductance of the following resistor. That is so simple, right? If you want 5 ohm here, you want G equal 1 over 5, 0.2 F. Okay, we'll be go to that thing, and I will be stop it, and we'll be continue it tomorrow. Ohm law. You see, this is a circuitry here. On this circuitry, you can get a power supply here and one resistor. Like the same thing, the lamp, the headlight in your car. That's it. So the current will be flowing through the resistor. Now, the relation between the voltage, the current, and the resistor, that we'll be talking about Ohm's law. Okay. E, that means the voltage equal I times R. Okay. Where E apply voltage in volt, I will be current in ampere, R will be resistance in ohm. So basically, Ohm law, they get 3 formula. From this E equal I times R, you can calculate I. I equal E divided to R, or R equal E divided to I. Okay? And now, the lamp in this figure draw 25 milliamp. When connect to a 6 voltage, what is its resistance? So you apply the Ohm law. R equal E divided to I. 6 volt divide 25 times 10 minus 3. Why times 10 minus 3? The thing is the current they given you milliamp. And this formula, they must be amp. So you have to converting into milliamp to amp. The difference will be 1,000. So that's why 25 times 10 minus 3 amp. That given you 240 ohm. Okay, so anyone learning basic electronics, then you have to know Ohm law. They get a basic tree formula here. The relation between the voltage, the current, and the resistance. Okay, voltage will be equal I times R. I must be in ampere. R must be in ohm. If you want to calculate the current I will be equal E divided R, or R equal E divided to R. Okay, and this is just formula to calculate the power. That means you understand when the current goes through the resistor. Okay, and electrical will be converting to the heat. The thing is you touch on the headlight, you can feel hot. Okay, and that is the power they be dissipated. So the formula will be, first formula P equal I square times R. Okay, or you can calculate P equal V square divided to R, or P equal V times I. Okay, either formula will be working the same. However, in this formula, P unit must be watt. How many watt? I must be in ampere. R must be in ohm. So that's why when you go in to buy your light bulb at your house, you can get 50 watt, 100 watt, or 150 watt. More watt, they need more current. The light will be better. Okay, but the current will be in more. That's why you have to pay more. Okay, so basically, up to this point, I want you to know about the Ohm law. If you want to calculate the voltage, they will be equal I times R. If you want to calculate the current, I equal V divided R. Okay, or you want to calculate the resistance, V divided R. Also, the formula to calculate the power when the current through the resistor, okay, we call it power dissipation, turn out to be a heat. Then you get three formula again. Okay, this is the first formula. P equal I times R, I square times R. Or this is the second formula. P equal V square divided to R. Or P equal V times R. Okay, and the unit of the power is watt. You understand is what you can get milliwatt, kilowatt, megawatt. Okay, the difference will be kilowatt mean power of 3. Okay, megawatt will be power of 6. Okay, I will be in ampere. Ampere you can get a microampere, milliampere, kiloampere, and you have to know what the power. Okay, resistor also. You can get an ohm, kilo ohm, mega ohm. You don't have a milli ohm. Okay. So up to this point, any question, anything, I can answer to you. The thing is, you get to the lecture during a week. after DC. This week, next week will be stuck with the AC. Okay. I try to get as much AC done, then hopefully few weeks left over. I will talking about RF. That means radio frequency. That will be teach you how the signal transmitted over the air. Okay, and how the signal will go into your radio. We're talking about transmitter and receiver. Like we're talking about when you're talking to your cell phone, what's going on, what happened, okay? When you're talking and the other one listen. So one you talking that the transmitter, and one the listen will be receiver. The basic will be the same, okay? That only thing, normally we don't have a time during fall semester or spring semester. The thing is, the time for the semester is not enough for electronic or for the digital. So that's why normally I just try to talking in the summer. And if we get that lecture done quick, then we'll be given to you more time in the lab. Okay, up to this point, any question? No? I stopped saying I did, guys. Okay, so any question to me? Okay, hello, Sam.
Yes, Mr. Pham.
Okay, for this semester, Mr. Tai and Mr. Hong Pham not teaching.
Okay.
Okay,
Okay.
so
So I'll go ahead and
tomorrow,
take care. So I go ahead and take care of the lab then.
tomorrow I will talking about the lab.
Okay.
Okay, so basically for now, if we open the lab on Wednesday,
Yes.
same time, right?
Right.
3 to 7,
Yes.
and open only room 250.
Okay.
I will be there.
Yes, sir.
Okay,
Okay.
so anyone don't know the location of the building for the lab, you have to let them know.
Okay. Let me go ahead and share the screen then. Sure. Okay. So pretty much, I recommend make sure you go to our website. So our website is, this is the name of the website. It's electronicstech.com. That is where I am on right now. So this is what it is. So this is so you come in here, you click and then you just type in the search bar up here, electronictech.com. And then the class schedule will be listed on this on a weekly basis. Today is the 13th. Tomorrow will be on the 14th, and we'll be staying on the Zoom lecture. And then on Wednesday is going to be this is to be announced, or we will give you updated on the Wednesday and Thursday. Okay, and this is listed everything that you will be having, and then the classroom, now it doesn't show you here, but you can go in here. You can go into contact on the menu on the top row. Click on contact and you come in here. This is the class location, okay? And it's going to be on the second floor. It's going to be on room 250. So you can click on the map here and it will give you the map location. Okay, so it's right here. It's off from University Avenue and 52nd Street. Okay, so 52nd and 54th Street. So it's going to be at this location right here. Okay, so that's the building. So you will be seeing this building right here. Okay, so this is 5348. So you can come here from the west heading east. This is what you're going to see, this building. Okay. So that is at 5348 University. Like I said, you can go to our website and then just click on the contact. And this is where the contact information of the instructors and everybody. So you have the classroom location. This is where we do all hands-on training. Okay. And then if anybody needs to contact me, this is my contact information. If you need some assistance or need some extra help, so you can text me to schedule an appointment. My hours are available. It's Monday to Friday. It's 1 to 9 p.m. And so if you need any extra help or if you need to work with me on Zoom, would be my Zoom contact and the password to get onto it. Or if you need to send me some information on an email and you need some help, you can also send it to my email. Okay. So you can contact me through texting. You can contact me and then where you can schedule an appointment that we can work on Zoom one-on-one. And then and you can also send me through email if you need some extra additional help. Okay. So that's pretty much it. Like I said, the website is one more time is electronicstext.com. Okay, so you just have to do is just type this into the search bar here, and that should bring you into here. Okay, like Mr. Pham said, everything that you will be needing. So right now, what you have to do is just get used to going through and navigating through here. So you got the home and then level. This is what you're going to be working on level. Like Mr. Pham said, you tech 1 for the summer, you're going to be AC1 and AC2. So you got some PDF file here that if you want to read ahead, that's fine. You go ahead and read ahead before you head to the lab. Now you're going to be doing some basic Ohm's law first. We're going to get you at the easy pace first, and before you starting to do the harder part, which is the AC1 and AC2. Okay, so like I said, just get used to the web page here. So this is the level, this is the handout, this is references, and then videos. This is where all your videos where Mr. Pham will be uploading the video for the lecture. You're going to be listed here for the summer semester. And then if you need some, if you want to do some, look at some from previous semester, you can also look at from previous semester, which is DC fundamentals. That's what he covered today on the DC fundamentals. So if you want to get ahead, you can watch some of these videos. That would help you out. Okay, and then if you need to look at some of the course materials, then this one give you what is going to be covered in Technician 1 and Technician 2. Okay, and the equipment. Okay, so this is talking about the lab vault, some of the things you can look at. And then if you want to know what is coming up, you can always click on the calendar and you can look in here and it listed. Okay, so summer session begin on the 13th, and then it listed here. And so you can scroll through and you can find out when is a holiday. Here is July 4th, which is Independence Day. So it's going to be a holiday here. So there's no class. So that's how you do it, just looking through it. So this is, so the summer semester will be end on August 27th. Okay, so that is for this semester. Okay, let me in the chat real quick. Okay. Okay, so the quiz and assignment are due by the end of each week. Well, the assignment you do as you're able to, like, right here. So you got assignment number 1, number 2, and number 3. Okay, so you're going to try to do them as best as you can, and then after that, try to work at it, make sure it passed before you save it and upload it to the website. Okay, so for example, if I open up the assignment number 1, so now I click on that and click that to open it up. But the quizzes usually they do the next day. And let me see what is going on here. Okay. Okay, so some of these, and then it will come up now. You're going to have some of these that pops up on here that give you some of the messages here. So this one has a protected view. So you want to do is click enable editing. Okay, once you click on that, now you can go through and edit. Okay, so here here you can start typing your name. So for myself, it's, for example, would be me. Okay, now I have to do it to solve these equations. So to say question number 1, solve this one. Okay, so the answer is, if I put in the answer, for example, if I said the answer is A here, for example, so therefore, if I type in A, the answer, they said it's wrong. So they said enter lowercase letter. So say A. And A is still not the right answer because I got 0 point. So if I say B, okay, so B is correct. So I got 1 point for being correct. So therefore, you have to go through every single one of this, make sure you got all of them. So for this assignment, there should be 13. You should have to get 13 points. Okay, once you get the 13 points, the status right here, it would change from fail to pass. Okay. And once that is done, make sure you save this assignment somewhere in your folder somewhere. For example, for me, it's going to be in my computer, and this is my computer. Now I put in for ETT for summer 2022. This is for my Tech 1 assignment. So this is Excel. So I'm going to save in my Excel file. Okay, so that's where I'm going to save it. And then after that, later on, once right now I haven't got it to pass, so once I have to work on it until it completely pass and make sure I save that. And then step 2, you're going to be coming in here and you're going to go to what called upload file. So I have to upload my homework. So I go here and click on upload file. I come in here and type in my first name. Okay, so Sam and my last name. Okay. And then right here, say choose file. So I have to click on that button and I have to go search for that assignment. Okay, so this is for the summer. That was Tech 1 assignment and it's in my Excel file. So it will be right here. So once I put it there, I click on open and now it stores right, it will be showing right here. Okay. So make sure, and then after that, you click on this green button that upload, okay? This is assignment for Tech 1. You just go directly, just as soon as you see your the assignment show up right here, you have to do it, just click on this green button to upload, okay? For student Tech 2 or student from previous semester that are moving to Tech 2, you have to do this extra step right here. So section 2, check this box. So you have to put for Tech 2 student, you have to put this one, put a check mark here and click upload for assignment for Tech 2 assignment, but this one is a Tech 1 assignment. So once you put it there, just click upload. So I'm just doing for example, okay? So therefore now it's uploaded into my file. And then to find out what you have turned into your file, you have to do it, just come down here, click on this green button, say retrieve. And if you're in Tech 2, you have to put a check mark here and then click on retrieve. But this is a Tech 1 assignment, click on retrieve. And there it is, assignment 1 basic math. Okay, so that was uploaded into my files. Okay. So I did have my spring semester assignment as well. So that's how you do it, just simple upload. So okay, so any question on that? Okay, let me go back to my home page. Okay. Okay, and then the quizzes, so like I said, the quizzes, we're gonna be giving you pretty much like every Monday at the end, pretty much at the end of the lecture, which is like, normally we do it about 6:30 on every, at the end of every lecture, mainly on Monday. Okay, but we don't have any quizzes coming up just yet, so just relax. And so like I said, as you can see with previous semester, you got the DC, and then after that they did a quiz number 1. So you're gonna have your first lecture, and then the following week they have the first quiz. Okay, and that quiz usually due before 12 noon of the next day. But the assignment, as soon as you complete them, go ahead and upload them. If you don't have time to, just work it throughout the semester. And if you need some extra help, you can contact me and I can work with you. Or if you need help in the lab, you can bring your assignment into the lab. So the next thing we want to do is, starting to get like you probably get like a memory stick that you can be able to save your homework. So that way, if you can bring it into the classroom and say that you have a certain homework that you need some extra help, save in your memory stick here and bring the classroom, and then you can open it in the computer in the classroom and I can help you with the assignment. Okay, so make sure you want to try to have a memory stick to save your work just in case. Okay. All right, any other question?
Okay, so if it's not, then good night, everyone.
Okay.
Good night.
Have a good
Good
one.
night.
But
Bye-bye.